All asymptotes, intercepts, and holes of a rational function f are labeled in the figure. Sketch a graph of f and find a formula for f. Well, first we see that f is a rational function, so f of x is the ratio of two polynomials. We're going to write this in factored form because that makes it easiest to see asymptotes, intercepts, and holes. So there's the division bar in my rational function. In the denominator, I see immediately that I have a couple of factors. First, I have an x minus 1 factor. Looking here, I have a vertical asymptote at x equal 1. That means the denominator will be 0 whenever x is 1, and that means x minus 1 will be a factor there. Likewise, I have a hole in the function at x equal negative 2. So if I write x plus 2 in my denominator, I will have division by 0 when x is negative 2. But the difference between the vertical asymptote and the hole is that a hole produces a factor of that gives 0 in the numerator as well as the denominator. So these factors will cancel out and produce perfectly well-defined values of x near negative 2. These will not blow up to infinity or minus infinity, as will be the case when you have 0 only in the denominator. So for the vertical asymptotes, we need a 0 only in the denominator. For holes, we need those zeros to occur simultaneously in the numerator and denominator. Now to finish this out, we have a 0 at negative 3. So x plus 3 will be a factor in the numerator. That will give us a 0 there. We need to make sure that our horizontal asymptote is correct. That horizontal asymptote is found by looking at the ratio of the highest powers of x. And if we multiply this out, we'd have an x squared plus some smaller terms on top. In the denominator, we'd have x squared plus some smaller terms there. And the ratio of those, the coefficients of the x squareds is 1. It's supposed to be 2. So we can fix that by putting a 2 in the numerator, which will make the lead coefficient 2. And the ratio of the numerator and denominator will be 2 to 1, or just 2. One last thing to check. We're supposed to have a y-intercept of negative 6, so we can check that our function gives us that. F of 0 is equal to 2 times 3 times 2 divided by negative 1 times 2. Simplifying does indeed give us negative 6 as it's supposed to be, and so our y-intercept is correct, and the expression for f of x is given here. We are supposed to also sketch the graph of f, and we can do that by recognizing that as x goes to minus infinity, it must approach this horizontal asymptote. It'll pass through the x-intercept, pass through the hole in the function, pass through the y-intercept, and approach the vertical asymptote at x equal 1. As it jumps past the vertical asymptote on the right, we have either with one of two options. It could start out towards minus infinity and come up, but then it would have to cross the x-axis as it approached the horizontal line. That doesn't occur because we had no roots there, no x-intercepts there, so it must indeed start out at plus infinity and come down towards the horizontal asymptote.